Hello ladies and gentlemen, this is another in the series of the Algebra 2 lessons that I've been giving you. I'm Mr. Green and this is a lesson on function basics. What did we do? We switched from Unit 2 to Unit 3. We have completed everything that's in Unit 2. You should have that all done. Do not forget, after 28 days, I put zeros in that on next Monday, and after the zeros are in, they become finalized in 28 days. So you want to get those zeros taken care of. Do not let them sit there for very long. I'm going to continue on with 3 function basics, okay? So, we're going to be able to represent a relationship in a mapping diagram, a table, and a graph. We're going to determine the domain and range from a given set of ordered pairs. Pairs table or mapping diagram. Excuse me. And then we're going to determine the domain and range from a graph. Okay? So, here's what we're going to look at. 3 terms I want you to make certain you understand. First of all, a relation. A relation is just a set of ordered pairs. It's nothing more than that. It's just the points that you're considering together. Doesn't mean anything except that it's a bunch of points thrown onto a graph. Just a set of ordered pairs. Domain. The domain are the x values in those points. Okay? That's the domain. That's where the relation is valid on the x graph. Okay? That's the domain. Range is the set of the y coordinates that are in those ordered pairs. Y values. Now when you're writing the domain and range, you don't repeat your numbers. Okay? They don't get repeated over and over again. They do in the ordered pair, but they do not in the domain and range. For example, if I give you this set of ordered pairs, 2, -6, 1, 4, 2, 4, 0, 0, 1, 6, or 1, -6, and 3, 0. Asking you to state the domain, you would go through and say, well, there's a 2, there's a 1, there's another 2. I'm not going to write that one down. 0, there's another 1. I'm not going to write that one down. And a 3. Now to write them in order, 0, 1, 2, 3. And that would be my domain. I would just write it that way and say the domain exists like this. Note the curly brackets around the outside of it. The curly brackets are to distinguish it from an ordered pair. In case there's only 2 numbers in the domain, we don't want to get confused and think you're writing down an ordered pair. Putting the little curly brackets around the outside helps do that. It helps us know that you're talking about a domain or a range. Note the D in front of it with the colon there. That's saying the domain consists of the set, and it gives you the set notation there. That's what we're talking about. It's called set notation. Now, the range. The range are the y values. So looking at my numbers up here, I've got -6, I've got 4, I've got another 4. I'm not going to write that one down. 0, I've got another -6 and another 0. So what do I got? 4, or 0, -6, and 4. Those are the 3 numbers that I would have in my range. Okay? So writing range and domain is not a problem if I have the numbers. So a relationship can always be written several ways. You can write it as ordered pairs, you can write it as a table or a graph, or maybe even as a mapping. You've already seen me giving it to you as ordered pairs. Let me show it to you in a couple of other ways. Here's an ordered pair, 3, 4, 7, 2, 0, -1. Notice I'm writing them in a table over here. X and Y at the top, but I'm writing them 3, 4, 7, 2, 0, -1. They're the same numbers, just expressed in a table and in an ordered pair. Okay, I can see that. That's pretty easy. If I wanted to create a mapping of it, I would just create 2 little ovals with the domain on the left and the domain and the range on the right, and the elements are not repeated in there, and then I'd connect the elements together with lines. Easy way of doing this. First of all, make the table. Then what do I see as my domain? Well, there are my domain numbers right there. I just don't have to write anything that's repeated in there twice, so I'm not going to write the 3 twice, okay? And then over on the other bubble, I'll do that, and I just won't write the 2 twice, because there's 2 2's. And I can just write some bubbles down. Bubbles. Okay? And I'm going to connect the 2, 2 to -6. I'm going to draw a line from 2 to -6. I'm going to draw a line from 1 to 4. I'm going to draw a line from 2 to 4. So I've got another line going in there. I'm going to draw a line from 0 to 0. I'm going to draw a line from 1 to negative 6. 1 to negative 6. I'm going to draw a line from 3 to 0. That simple. Mappings are not hard, especially if you have that table to write the numbers down from. It's easy to start off that way and write them down. Okay? So, what's the difference in a relation and a function? A function is a relation in which the members of the domain, the x values, are never repeated. That's all it is. If you don't repeat an x value, then it can be a function. If you repeat the x value, it's not a function. Can I repeat the y values? Sure, repeat them all you want. Just don't repeat the x values. Let's go back here. This one, I have 2 3's in it. Is it a function? No, it's not a function. It's just a relation because there's a repeated x value there, not a function. Let's look at this one. Let's see, I've got a 2, a 1, a 2. Not a function because I ran into a second 2. Once I run into 2 2's, or to 2x, an x that's repeated, not a function. Stop right there. Don't even go any further with it. Okay? And I want you to notice, y values are repeated. Negative 6, negative 6. Doesn't make any difference. It's the x values that we're talking about there. That's what makes it a function. Okay? So, discrete functions just consist of points. So here, these are points that we were looking at in this relationship here, right? If it could have been a function, that would have been called a discrete function. Just a list of points. They're not connected together with a line. They are just the points. A continuous function can be graphed with a line or a smooth curve that contains an infinite number of points. Remember, there's an infinite number there. We might only put 1 or 2 on there that we know, but once we connect them with a line, it means everything in between there is counted as well. Okay? So, let's look at some of these. Is this one a function? Let's see here. 3, 7, 0, negative 2, negative 5, 3. Nope, I got a 3, and there was a 3 here to begin with. Not a function. We repeated something in the domain, not a function. How about this one down here? 4, 5, 8, 9. No repeats in that. Yes, it is a function. Okay? There's no coordinates in the x that are repeated, nothing in the domain repeated. It is a function. That's the way you can tell. Quick and dirty. Nothing difficult about it. Now, if I'm looking at a graph of a function, I don't really want to have to go through and write all the points down to see if they've got a repeated x value. So one of the things we can do is we can do a test called the vertical line test. The vertical line test is I'm going to take a vertical, straight up and down line, up and down, not right to left, up and down, vertical line, and I'm going to go along the function. If I touch the function twice with that vertical line, that means an x value must have been repeated, and it's not a function. Okay? If I'm following along it and I only touch it at one point, then it is a function. Now, it's easier to show this one than it is to actually talk about it. So I'm going to take a little vertical line here. My vertical line, like this. And I'm going to grab my little vertical line and I'm going to move it. Okay? If I take my vertical line and it only touches that red line one place at a time, function. I'm going to take my vertical line and run it along here. I'm touching 2 places. Not a function. I'm going to come along over here. Am I touching that line more than one place? Yes, multiple places. Not a function. How about this one? I go along that red line. I don't see it touching in more than one place at a time. Function. How about this line over here? Well, I'm going to only touch it in one place at a time. Function. How about this one here? Is it a function? See, I'm only touching it once, only touching it once, only touching it. I went through all the difficult parts and only touched it once. It's going to be a function. How about this one? No, my vertical line's touching it in more than one place. Not a function. How about the circle? Circle is not a function. See how it's touching it in more than one place? Not a function. Okay? So, how about this graph here? Is that one a function? I only see my vertical line would never touch it in more than one place. I would say that yes, this one is a function. Okay? How about the domain on this one? See the arrows on the end here? That means it goes on and on forever, ever and ever and ever and ever, right? That means it is eventually going to fill up the entire values of all the real numbers. That's why I'm putting an R like that. That means all real numbers. The range, same thing. It looks like it's going to be all real numbers. Okay? All real numbers covered. This one down here at the bottom, the parabola. Does that look like it's going to be a function? Well, yes, that one's going to be a function. I know that a parabola is a function. Domain is going to be all real numbers. It's going to start at negative infinity and go to positive infinity. How about the range? Ooh, range is different. See, it doesn't go below this number, does it? So it's all real numbers. I didn't do that right. All real numbers greater than -3. If I don't write it that way, I would not be getting credit to it, okay? It's really written as, it's the set of all real numbers. Come on, Charles. You remember this from your calculus. You used to do it all the time. Hated doing it, okay? Okay, try again. It's the set of all real numbers where x, or y, because we're talking about the range, greater than -3. All real numbers such that y greater than -3. That would be my range in that situation. Let's try it again. First one there. Is that a function? Yes, it is a function. Domain on it. Even though it doesn't look like it, the domain on that one is going to be same thing, all real numbers. How about the range on that one? Same thing. It's going to hit all real numbers eventually. Okay? How about this one down here? You know what? No arrows. This is the first time we've seen one with no arrows on it. That means my domain is a limited number here. It's going to go from -2 greater than or equal to x greater than or equal to 2. Did I write that right? Don't think so. I got my alligators backwards, don't I? Okay, let's try it again. Okay, -2 less than or equal to x less than or equal to 2. Better. Okay, I looked at it and it just didn't look right. Sorry. Okay, got to point at the smaller one. It wasn't pointing at the smaller one, it's pointing at the bigger ones every time. So that's telling you the domain goes from -2 to 2, and it's inclusive. Inclusive in the sense that it includes the -2 and the 2. Okay? What's the range? Well, the range in this situation, it starts at 0. Doesn't go into the negative numbers, does it? Okay? And it's greater than or equal to 0, but it's less than or equal to 2. That's the range. Is it a function? Well, we said earlier a circle wasn't a function, was it? But let's look here. Let's draw a little vertical line and see if we can do a little vertical line test on this one. So there's my vertical line. I grab that vertical line and I run across it. I don't think I'm touching it in two places there. I think I'm only touching it at one. And 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. It looks like it's awful close there, but if you remember a function and the function of a circle, and this is a semicircle, it really never touches it in more than one place. Okay? So in this situation, yes, this one is a uh, function, and that would be my domain and my range on it. Okay? Couple more. Does this one represent a function? Yeah, it does. I only see it touching in a vertical line touching it in one place. What's my domain? It's going to be x greater than or equal to 6. What's my range going to be? Range is going to be 0 less than or equal to y less than or equal to, well, you know what? It's just going to be that, because it looks like it goes on forever, doesn't it? So y is going to be greater than or equal to 0. How about this one down here? Toughie. Yeah, it's a function. Just knowing how these particular things work, because these two lines are going to be what's called asymptotic. Asymptotic is the MC Hammer statement. Can't touch this. Dun, 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 dun. Okay, so these two lines are going to be asymptotic to that line right there. That means they're never going to touch that line. They're going to get close to it, but never get there altogether. Okay? That's what asymptotic means. It means that they don't ever touch that number. Don't ever get there. So my domain is going to be all real numbers except for, let's see if I can write this correctly, all real numbers except x equal to 3. X not equal to 3. Okay? And my range is going to be all real numbers except for y not equal to 0. Why? Because it won't ever equal that 0 value right there. It's also asymptotic to that one. Okay, going forward. Delia takes a 10 minutes to drag her sled up a 200-foot slide, a foothill. Okay? So you're reading a word problem like this, and I know they want me to graph it. I'm just going to sit here and say, okay, these are going to be minutes down here. 4, 5, 6, 7, 8, 9, 10, 11, and 12 minutes. Okay? And it's a 200-foot hill, so I'm going to be, nice. I don't want to really put a lot of time into making a graph here. So 50, 100, 150. No, that's not 750. That's 150. Okay? And 200. Okay? So she takes 10 minutes. So she starts at 0, and there's 0, 0 is where she started right there. And she's going to go to 10 minutes, and she's going to go all the way up to this 200-foot hill. That's right there. Okay, I found some points. What do I do with those 2 points? Well, she drag it up there. Oh, let's drag a little line there. That's the way it would look. Okay? The next statement is that she sits there for a minute. Okay? That meant I set 1 minute at 200 foot. So the line would go across like that. And then from here, it takes her 20 seconds to slide down the hill. Well, 20 seconds is about a third of a minute, so it's going to be right in there somewhere. So my line is going to go from right there to right there like that. And I think I just graphed out that function. Is it a function? Yes. Vertical line. Never vertical line touching those things more than 1 point. Okay? Moving forward. This lady is driving on the highway from a traffic stop. It takes him 2 minutes to increase to 50 miles an hour. Well, that means I need to start labeling some time going across here, right? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, 10, 11, and 12. Okay? So it's starting from a stop sign. That means 0, 0, not going anywhere at all. We're going to go up in miles per hour. And let's say this 25 miles or 20 miles an hour. This one's 40 miles an hour. And this one up here is 60 miles an hour. Okay? Anything magical about what I'm doing there about deciding on the scales? Not really. Just trying to be consistent and even. Okay? So from 0, 0, it took him 2 minutes to increase to 50 miles an hour. 1, 2 to 50 miles an hour. There's my point right there. Drives at a consistent speed for 10 more minutes. Well, I'm at 2. That means I got to go out here to 12. And those are the points I'm going to be graphing. So I'm going to go from 0, 0 to 250, and from 250 to 1250. Ta-da! We just expressed a word problem graphically. Okay? So, basic functions in Algebra 2 here. You represented a relation in a mapping diagram, a table, and a graph. We determined the domain and the range from a given set of ordered pairs, a table or a mapping diagram, and we determined the domain and the range from a graph. Okay? Don't forget, guys, that if you're sending me messages, make certain you're including the fact that you're in Algebra 2 so that I can keep track and I can find your records real quickly. It just helps us all together. Okay? So, I'll look forward to seeing you next time.